Chapter 9, Section 9.4 is going to be stoichiometry involving limiting reactants and percent yield. So in our first problem, we're told that we have a combustion reaction with CH4, and just from that we should be able to write our equation. CH4 plus O2 yields CO2 and H2O, because that's how all combustion reactions are. And they tell us that after it gives CO2 and water, what is the theoretical yield of CO2? So this is what we're trying to find. They don't specify in grams or moles, so we're going to just find our theoretical yield in moles. And then we're given 10 grams of methane, 10.0 grams of methane, which are mixed with an excess of oxygen. Identify the limiting reactant. Well, we have an excess of the oxygen as it is, therefore the CH4 is our limiting reactant. Or we could also call it the limiter. So we'll actually place this here in the blank. 10.0 grams of CH4 is my limiting reactant. Now that I know what my limiting reactant is, I'm going to go ahead and solve for the theoretical yield. We're going to stoich from 10.0 grams of CH4 to moles of CO2. And so I'll start by putting my 10.0 grams of CH4 over 1 times, draw a line, bring down your grams of CH4. I want to go to the periodic table to get the molar mass, which is going to be 16.05, and that equals 1 mole of CH4. Times, draw a line, bring down mole. Remember, our goal is to get to mole so that we can do a mole-to-mole ratio between CH4 and CO2. So I want to go from moles of CH4 to moles of carbon dioxide. And so the ratio here is a 1-to-1 ratio. That's coming from here and here. This is 1-to-1. Now that I'm at moles, I'm finished setting up my problem, and I'll calculate the answer. I'm going to do 10.0 divided by 16.05 equals, and we want to use proper sig figs because we started out here with 3 sigs. We want our answer to also have 3 sig figs. So my answer is actually going to be 0.623 moles of CO2. And this is my theoretical yield. Number 2 is very different. We've been given the equation, and first we have to balance it. You always have to start with a balanced equation. So we have 3 silvers now on both sides, 1 phosphorus on both sides. We have 3 sodiums on both sides, 3 nitrogens, and 12 oxygens. So my ratio is 3 to 1 to 1 to 3. I have 2 givens in this problem. 200 grams of silver nitrate and 200 grams of sodium phosphate. One of these is going to be the limiter, and one of these is going to be the excess. But which one is which is the question. What we're trying to find is what is the theoretical yield of silver phosphate produced in grams. So I want to know how much silver phosphate is produced in grams. And we have to identify what is our limiting reactant. So you have to do 2 different stoich problems. We're going to do our first stoich, stoich number 1, from the 200 grams of silver nitrate to grams of silver phosphate. And our second stoich will be from sodium phosphate to silver phosphate also. We want to see how much each of these will theoretically yield, and then we can use that to determine our limiter and our true theoretical yield. So here are both of the stoich problems. And you can see after we have set up both of our equations, we end up with the following possible theoretical yields. 164.26 grams of silver phosphate and 510.65 grams of silver phosphate. So these are both my potential theoretical yields. However, because something has to run out first, I'm limited by the limiting reactant. So the smaller theoretical yield is always going to be the true theoretical yield. So our theoretical yield is 164.26, which means this came from the excess. It's not actually anything. It's not a theoretical yield or anything. It's a meaningless number. However, we can use that to identify that because this is my theoretical yield, that makes this my limiting reactant. And because this was in excess, that makes this my excess reactant. And so my limiting reactant would be written as 200 grams of silver nitrate, and my theoretical yield would be 164.26 grams of silver phosphate. Okay, number 3, what is the theoretical yield? So I'm trying to find the theoretical yield in liters of hydrogen at STP. So we're looking for hydrogen and we want to know how many liters. Remember that this means we're going to use our conversion factor. 1 mole equals 22.4 liters of any gas at STP. And hydrogen is a gas and it is at STP. So we're allowed to use that conversion factor. We also are given 50.0 grams of magnesium and 75.0 grams of hydrochloric acid. So we don't know which one is our limiter or which one is our excess, so identify the limiting reagent. And we've been given an actual yield of hydrogen gas to be 19.36 liters, and the actual yield will be used with the percent yield, which is percent yield equals the actual yield divided by the theoretical yield times 100. So we're going to save that 19.6 liters for later when we determine what is our percent yield. So first, what has to happen is we need 2 stoichs. One from magnesium to hydrogen, that's stoich number 1, and a second one from hydrochloric acid to hydrogen as well, so that'll be stoich number 2. And here are our 2 stoich problems fully set up. One thing we forgot to do that you want to make sure of is that we have a balanced equation, which means we should have a 2 in front of hydrochloric acid. So here are the 2 setups, and you'll see that we have 2 possible theoretical yields of 46.1 liters and 23.0 liters. Since 23.0 liters is the lesser of the 2, this is the true theoretical yield. That means 46.1 liters really isn't anything. If 23.0 liters is our theoretical yield, then that means that what I used to get that theoretical yield is my limiting reactant, or the limiter, which makes my 50.0 grams of magnesium the excess. So my limiting reactant is 75.0 grams of HCl. My theoretical yield is 23.0 liters of hydrogen. So now what is the percent yield? We were given an actual yield in the problem of 19.6 liters. That's this right here, 19.6 liters. And that's of hydrogen. So 19.6 liters, which is my actual yield, divided by the theoretical, 23.0 liters, times 100 will give me a percent yield of 85.2%.